Welcome Pre-Algebra to Chapter 2, Operations with Integers. We're going to be taking a look at the first section, Section 2.1, Integers and Absolute Value. We have a number of vocabulary words to be working with this particular section, so we're going to take a look at negative numbers, positive numbers, integers, coordinate, inequalities, and absolute value. The first two vocabulary terms refer to negative numbers, and those are simply numbers that are less than zero, and positive numbers, those are numbers that are greater than zero. Sometimes you might see n is less than zero, that means negative numbers, or n greater than zero, and that refers to positive numbers. We will often talk about integers, and integers are negative and positive whole numbers that include zero. Sometimes I like to talk about integers as number line numbers. Down here I'm going to draw a number line, and you'll notice that we have whole numbers that are negative and positive and including zero. So that's why sometimes I refer to integers as number line numbers, because you often see them on a number line. The next term is coordinate. The word coordinate refers to the number that corresponds to a location on a number line. So I could refer to, let's put a dot here at this place. The coordinate here is 2. So the location on a number line that gives me a particular position. So the coordinate for that green dot is 2. Typically, when we talk about inequalities, we're talking about a math sentence that compares values using the following symbols. This one here is less than or equal to. This is less than. This is greater than, and this is greater than or equal to. Your textbook will focus primarily on these two terms here, less than and greater than. And sometimes you'll see in other books, this is also an inequality sign. It says specifically that two things are not equivalent. For instance, I could replace this square with, or this rectangle between 3 and 4 with a comparison symbol. Clearly they are not equal. If I choose one of the two symbols here in the center that our textbook is going to use, we would use this symbol, less than. To read 3 is less than 4. Sometimes you probably remember that they talk about this is an alligator and the alligator wants to eat the greater thing. I don't know how your teacher may have taught it to you in the past, but keep remembering or keep in mind that the open portion of your inequality symbol is going to be open towards the greater value. When we think of absolute value, we need to think about the number line and a number's distance from 0. So as we look down at this number line, when I think about the number 3 right here, the distance from 0 is 3. If I think about the number -3, the distance from 0 is still 3 spaces. We don't consider distance in this case negative or positive. Therefore, the absolute value, that's what these straight lines mean, the absolute value of -3 is 3, and the absolute value of 3 is 3. What do you think the absolute value of -4 would be? If you guess +4, you're correct. The answer to an absolute value question is always positive. The answer to an absolute value question, if you're just trying to figure out, or if you're evaluating an absolute value, you're always going to get a positive answer for whatever is within the absolute value. And we'll talk more about that. Now that we've covered our vocabulary, let's take a look at example 1, integers used in real-world applications. So what we're going to do is we're going to read each of these sentences, and we're going to think of what integer, negative or positive or 0, we're going to use for each situation. So in this first one, 23 degrees below 0. We know things that are less than 0 are negative, so it makes sense to do -23 here. How about 11 inches more than normal? That means there is more. More means that is additional, so you can do +11 or simply 11. When we write 11 without a plus sign, we recognize that that's a positive number. How about this one? A loss of 8 yards. When you lose something, that's negative, so we'll do -8 there. And a deposit of 15. If you think about depositing money into your bank account, you'll realize that that's a positive experience, and then we'll put a +15. Example 2 has us comparing two integers. So let's write two inequalities for -1 and 2. So I could write -1 is less than 2, or I could write it differently. I can write that 2 is greater than -1. Let's check out example B. Example B asks us to replace this symbol with less than or greater than or equal to make this situation true. So here's our situation, -3, and then we've got these empty brackets here, and then -7. We know they're not equal. Which one is greater than, which one is less than? Sometimes this is a little bit tricky, but if we think about a number line and our placement of these numbers, we'd have 0 here, 1 would be here, -1, -2, -3, and then back here would be -7. So from looking at a number line, we recognize that -3 is actually greater than -7 because it is further to the right. Example 3 requires us to write these numbers from least to greatest, and so we're going to start with the smallest number. Hopefully you realize that that's -5. The next smallest number would be -1. Then we get to 0. Then we have 1, 2, and then 4. So when we write it from least to greatest, basically what we're doing is we're writing it as if they're on a number line. So that's our answer. I should put commas between these guys. There we go. So example 4, here's our next look at absolute value. And so we're going to evaluate each expression. So we remember evaluate means to give an answer, numerical answer, and we're going to do just that. The absolute value of -4 is indeed 4, because when I think about the distance from 0 to -4, I know that there's just 4 spaces. Here, this is a little tricky. Let's think about what we have here. So first we're going to take the absolute value of 8, and then take the absolute value of 5, and then finally we'll subtract them. The absolute value of 8 is 8, the absolute value of 5 is 5, and then we subtract and we get 3. Our final example that includes absolute value, and also our final example for this section, is an algebraic one. So we're going to evaluate this particular expression if x is equal to -2. So we do exactly as we usually would. We just rewrite the problem where we replace the variable with its value. Since x is equal to -2, I now have 6 plus the absolute value of -2. 6 plus the absolute value of -2 is really 6 plus 2, and clearly my answer is 8. All right, friends, here's our assignment. Given this video, I hope it makes pretty good sense. I've also posted the assignment onto your packet, so if you forget to write all the problems down, you can check there. Have a good one.